Myself, Milan Patel, Assistant Professor at LJ Institute of Engineering and Technology. Today's topic is about angular measurement. Today's lecture, we will cover one term which is local attraction and various examples related to local attraction. Let's start with local attraction. So what is local attraction? When the compass is set up around iron or steel structure or under electric cables carrying high voltage, then the magnetic needle of the compass will not point magnetic north, or it is deflected from its normal magnetic north direction. This deviation of needle from magnetic north or its original position under the influence of magnetic substances is called as local attraction. The bearing measured from such stations are not correct and needs to be corrected. They are required to be corrected before floating the towers. Okay, this is called as local attraction. This is a deviation of magnetic needle due to magnetic things or magnetic substances. Okay. Now, next is sources of local attraction. From where this local attraction is come? The sources of local attraction can be divided into two types. First is natural sources, which are naturally available iron or rocks or magnetic type of rocks, and artificial sources like steel structures, railways, iron pipes, electric lines, metallic chains, arrows, ranging rod, bunch of keys, your mobile phone. Okay, these are the artificial sources or man-made sources. Next is how can we detect this local attraction? For detection of local attraction, we have to find out the difference of forebearing and back bearing of any line. If the difference of forebearing and back bearing of that line is equal to 180 degree, means the stations of that line are not in local attraction. If the difference of forebearing and back bearing does not equal to 180 degree, means the stations of that line are affected by local attraction. This is how we can find out the stations affecting local attraction. After find out the station affecting local attraction, we have to correct the values measuring by the stations. So for correction of local attraction, we can use two methods. First is using corrected angles. For that method, first we have to find out interior angles of observed bearings. After find out interior angles, we have to check that angles by sum of interior angles is equal to n minus 4 into 90 degree. This is the check for sum of interior angles. After checking, if check is not satisfied, total error is equally distributed and corrected angles are found out. And then using corrected angles, starting from unaffected line, bearings of all lines are corrected. Okay, so using corrected angles, the new bearings or corrected bearings are found out by this method. Second method is without using corrected angles. In this method, interior angles are not required. Okay, starting from the unaffected line, bearing of other lines are corrected by finding the amount of correction at each station. If all lines are affected, then the line with minimum error is considered for starting. FB and BB of this line is adjusted by distributing the error equally, and then starting from this adjusted line, FB and BB of other lines are corrected. This is how we can correct the bearings using this second method, which is without using corrected angles. These two methods are used in examples. Let's see the example. So the second topic is example of local attraction. We will start this. The following forebearing and back bearing are observed while running a closed towers A, B, C, D, E, A. Find out which stations are affected by local attraction and calculate correct bearings and included angles, means interior angles. Also apply necessary checks. This is the data given. First, we have to find out the stations which are affected by local attraction. For finding out the stations which are affected by local attraction, we have to find the difference between forebearing and backbearing. Okay? If the difference between forebearing and backbearing is equal to 180 degree, means no local attraction in that stations. If the difference between FB and BB does not equal to 180 degree, means there are the chances of local attraction in that stations. So first we have found out the difference of forebearing and backbearing. In line AB, the difference of forebearing and backbearing is equal to 180 degree. So line AB, which connects station A and station B, this station A and station B are free from local attraction. Then in line BC, the difference is 181 degree, means the difference does not equal to 180 degree, means there is a chances of local attraction. Here in BC, B is free from local attraction, so there is chances of local attraction in station number C. In CD, the difference is 179 degree 30 minutes, is also does not equal to 180 degree. Station C is affected by local attraction, so it can be the chance in station D also. It is also in affection of local attraction. Line D, the difference is 179 degree. The line D is made by station D and E, so this station D and E are also affected by local attraction. In line EA, the difference is 177 degree 30 minutes, does not equal to 180 degree, but station E is already free from local attraction, as line AB, difference of FB and BB is 180 degree. So here you can clearly say that this difference of 177 degree 30 minutes is because of station number E. Okay, so by these values of differences, we can remark this station A and B are free from local attraction and station C, D and E are affected by local attraction. Okay. First, we have used first method by calculating included angles. Okay, for calculating included angles, we have to first draw a traverse. How to draw a traverse? We have just discussed in the last lecture. Okay, for drawing the traverse, we have to use forebearing of each line. So after drawing the traverse using forebearing of each line, we have inserted the values of back bearings like this: back bearing of AB, back bearing of DA, back bearing of AB, back bearing of BC, back bearing of CD, and back bearing of DE. Okay, this is called as traverse ABCDE. Okay. After drawing traverse, we have to calculate the interior angles, because in first method interior angles are required. So for calculating interior angles, we have to draw this table, because this is a WCB type of method. We have to calculate interior angles by using this table. Okay. So station A is equal to, in station A, forward line is AB, backward line is EA. So difference of FB and BB is 126 degree 30 minutes, which is less than 180 degree. So the angle is interior angle. Okay. Angle is equal to BB of EA minus FB of AB, 194 degree 30 minutes minus 68 degree 126 degree 30 minutes, which is interior. Angle B, BB of AB minus FB of BC, 248 degree minus 138 degree 110 degree, which is less than 180 degree, means interior angle. Angle C, BB of BC minus FB of CD, 319 degree minus 193 degree 126 degree, which is interior. Angle D, here FB of DE minus BB of CD, 302 degree 30 minutes minus 13 degree 30 minutes. The difference is 289 degree, which is exterior angle. So we have to convert this exterior angle into interior angle by deducting this value from 360 degree. So 360 degree minus 289 degree, 110 degree, which is interior angle. Sorry, 360 degree minus 289 degree, which is 71 degree. And the last is angle E, which is BB of D minus FB of EA, 123 degree 30 minutes minus 17 degree, which is 106 degree 30 minutes, which is interior. This is how we can calculate the angles. After calculation of interior angles, we have to check these interior angles. So for checking interior angles, we have to sum of interior angles. Here sum of interior angles is 540 degree. Sum of interior angles should be 2n minus 4 into 90 degree. Here number of stations or number of lines are 5. So n is equal to 5. So sum of interior angles should be 2 into 5 minus 4 into 90, which is 540 degree. Here our sum of interior angle is 540 degree. It should be 540 degree. So no correction is required. Above finding values of interior angles are corrected one. So after finding out this corrected interior angles, we can go for calculation of corrected bearings using these corrected interior angles. For that, we have to report this traverse. We start with the stations which are free from local attraction and the readings which are corrected one. So the station A and station B are free from local attraction. So the readings taken from station A and B are the corrected one. So for station A, you can clearly see two readings are taken. Fore bearing of line AB, which is 68 degree, and back bearing of line EA, which is 194 degree 30 minute, which are the corrected one. So BB of EA 194 degree 30 minute and FB of AB 68 degree, which is correct because in station A there is no local attraction. Station B is also free from local attraction. So readings taken from station B is also free from, also corrected. So in station B there are two readings are taken. BB of AB, which is 248 degree, which is corrected, and FB of BC, which is 138 degree, is also corrected. Now next, station C, D and E are affected by local attraction. So the readings taken by these three stations are not corrected. So we have to correct these bearings. Okay, starting from station number C, we have the data of FB of BC 138 degree, which is corrected in station number B. Okay, using this FB of BC, we can find out BB of BC. Okay, how to convert FB to BB? We have discussed in the last lectures. Okay, so BB of BC is equal to FB of BC plus 180 degree because here FB of BC is less than 180 degree. So to find out BB of BC, we have to add 180 degree. So BB of BC is equal to FB of BC plus 180 degree, 138 plus 180 degree, 318 degree, which is corrected. Okay, after finding out BB of BC, we have to use the angle C. The value of angle C is equal to, clearly C is equal to BB of BC minus FB of CD. Okay, we have the value of angle C, which is 126 degree. So using this formula, angle C is equal to BB of BC minus FB of CD, we can find out FB of CD. Okay, FB of CD is equal to BB of BC minus angle C 318 degree minus 126 degree, which is 190 degree. So using this corrected angle as well as corrected bearing, corrected angle means C, angle C, which is already corrected, and BB of BC is also corrected. By using these two corrected values, we can find out the correct FB of CD. Okay, this is how we can find out the readings of angle C. Okay, next, station D. In station D, we have the value of FB of CD from station number C. Okay, the FB of CD is equal to 192 degree, which is already corrected. Using this value, we can find out BB of CD, which is FB of CD minus 180 degree. Why there is a minus sign? Because here FB of CD is greater than 180 degree. For greater than 180 degree, we have to deduct 180 degree from FB value. So BB of CD is equal to FB of CD minus 180 degree. 192 degree minus 180 degree, which is 12 degree, which is corrected. Okay, now we have to use this angle D. Okay, so here angle D can be found out by this equation. FB of DE minus BB of CD gives the angle D. Okay, so FB of DE is equal to BB of CD plus angle D. 12 degree plus 289 degree, 301 degree is the corrected one. Okay, next, station E. Here above FB of D is given 301 degree, which is corrected. By using this FB of D, we can find out BB of D by deducting 180 degree. So BB of D is equal to 121 degree, which is corrected. Now using the angle E, we can find out FB of EA. Okay, so angle E is equal to BB of DE minus FB of EA. So FB of EA is equal to BB of DE minus angle E. 121 degree minus corrected value of angle E, which is 106 degree 30 minute. So FB of EA is equal to 14 degree 30 minute. This is how we can find out corrected bearings of the stations which are affected by local attraction. Now we will check these readings is correct or not. For correcting this reading, we have the data of FB of EA. If we found out BB of EA, we have to add 180 degree. So 14 degree 30 minute plus 180 degree, 194 degree 30 minute, which is shown in figure already. So this is how we can check our bearings. Okay. Now we will use our second method, in which there is no need of calculation of interior angles. Okay. We have the data of this traverse. Station A and B are free from local attraction, so the readings taken from station A and B are corrected. So these values are already corrected. Now station number C, we have to find out BB of BC using FB of BC. This is similar as the first method. BB of BC is equal to FB of BC plus 180 degree, 138 degree plus 180 degree, 318 degree. This is the correct value. This correct value of BB of BC is compared with the value given in the example. Okay. By comparing this, we can find out the error at station number C. Okay. BB of BC in given example is 319 degree, and we have found out the BB of BC is 318 degree. So there is a 1 degree error. To correct this error, the correction at station C should be minus 1 degree. So minus 1 degree can be implemented in the next reading of station number C, which is FB of CD. FB of CD, which is given in example, is 193 degree. We add our correction, which is minus 1 degree, into FB of CD, which is given in example. We can find out correct FB of CD, which is 192 degree. Okay, this 192 degree is similar, which is calculated by first method. Okay. Next is station number D. We have the data of FB of CD 192 degree. We can calculate BB of CD is equal to FB of CD minus 180 degree, 192 degree minus 180 degree, 12 degree. Okay, we have to compare this BB of CD value to the given example value. Okay, and find out the error at D. BB of CD given in example is 13 degree 30 minute, and we have found out BB of CD in 12 degree. So the error at station number D is 1 degree 30 minute. To correct this error, the correction at station D is minus 1 degree 30 minute, which will be implemented in the next reading, which is FB of D. So FB of D, which is given in example, is 302 degree 30 minute, and we will add this correction minus 1 degree 30 minute. So the corrected FB of D is equal to 301 degree. Next, station E. We have the value of FB of D 301 degree. By using this value, we can find out BB of D 301 degree minus 180 degree, 121 degree. We have to compare this BB of D to the given example value. The BB of D in given example is 123 degree 30 minute, and we have found out the corrected BB of D, which is 121 degree. So the error at station number E is 2 degree 30 minute. Okay, we have to correct this error by correction minus 2 degree 30 minute. This correction will be implemented in the next reading, which is FB of EA. So FB of EA, which is given in example 17 degree, adding this correction to minus 2 degree 30 minute, we can find out correct FB of EA 14 degree 30 minute. This is similar as calculated in method number 1. In this method, you can also check these bearings by calculating BB of EA. So BB of EA is equal to 14 degree 30 minute plus 180 degree, 194 degree 30 minute, which is already found out or already corrected in station number 8. Okay, this is how we can calculate bearings using second method without using interior angles. Okay. By any of the above two methods, we can correct the bearings which are affected by local attraction, and the final readings of all lines AB, BC, CD, D and EA are shown in this table. Here all differences are 180 degree. So this is the corrected FB and BB values or corrected bearings values. Okay, this is how we can calculate interior angles and corrected bearings. That's all about the example of local attraction. I hope you all understand what is local attraction, what are the sources of local attraction, how can we detect local attraction, how can we correct the bearings which are affected by local attraction in the examples. See you soon in the next lecture.